How do watchpoints find memory corruption? Imagine trying to catch a sneaky mistake in your code that causes your program to behave oddly or crash. Sometimes, these bugs hide deep in memory, making them hard to spot. That's where watchpoints come in. They are a special tool used by programmers to track down memory corruption. When you set a watchpoint on a specific piece of memory, the debugger keeps an eye on it during program execution. If the program tries to read from or write to that memory, the watchpoint triggers. This pause lets you see exactly what was happening at that moment. The key idea is that watchpoints are like a security camera for your program's memory. They monitor specific addresses or ranges of memory. When an access occurs, the debugger gets notified immediately. This is especially useful for catching bugs like buffer overflows, where data spills over the allocated space, or use after-free errors, where your program tries to use memory that has already been released. There are two main types of watchpoints: hardware and software. Hardware watchpoints use special parts of the CPU called debug registers. These registers are designed to watch certain memory addresses with very little impact on performance. For example, some processors like ARM Cortex-M have a data watchpoint and trace unit that can monitor memory very precisely. They can trigger an interrupt from the processor itself when the watched memory is accessed. Software watchpoints are different. They are managed by the debugger and often involve inserting extra code into the program. This method can watch more memory locations or larger areas but might slow down the program because the debugger has to check memory accesses explicitly. Advanced debugging tools combine these methods with techniques like tagging memory bytes or watching entire objects. This helps detect when a program accesses memory that it shouldn't, like after freeing it or going beyond the bounds of an array. When you set a watchpoint on a variable or memory area, it keeps watch during the program's run. If the program writes past the end of a buffer or tries to access memory after it has been freed, the watchpoint triggers right away. This immediate feedback helps you find the exact instruction responsible for the corruption. Using watchpoints saves a lot of time because they catch errors as they happen. Instead of guessing where the bug is, you see the problem at the moment it occurs. This is especially helpful in complex systems where memory issues can cause unpredictable behavior. Mastering watchpoints allows you to pinpoint and fix memory bugs more quickly, making your software more reliable and stable.